Bridges, section 6.1, rational expressions and functions. The first thing we need to understand is what exactly a rational expression is. So a rational expression is a fraction whose numerator and denominator are polynomials. So for example, a rational expression could be something like 3 over x plus 4, or 2x over x squared minus 4x plus 4, or x squared minus 5x over x plus 7. So basically some kind of polynomial over some kind of other polynomial. Now the first natural thing to talk about when we're talking about these rational expressions or rational functions is domain. And so what you have to be careful of when you're finding the domain is you basically want to avoid division by 0. Domain, avoid division by 0. Let's do some examples. Find the domain. All right, so let's say that f of x equals 4 over x minus 2. Now, if you think about it, you're wanting to find all the x values where division by 0 would occur, and you would want to exclude those from the domain, because in reality, the domain would be all the values of x that you could plug in and have an output that would be a real number that would make sense. So I look at this and I say, okay, what value of x would make the denominator equal to 0? Specifically, I look at this part right here, and I say, okay, what value of x would make that equal to 0? So I could even say off to the side, x minus 2 cannot be 0. And I can solve that by adding 2 to both sides. So x cannot be 2. Well, that's all well and good, except for domain, we usually list that in interval notation. So the idea is we would want to take that and we would want to remove 2, but have everything else in the domain. So therefore the domain, if I want all the numbers except 2, that would be from negative infinity to 2, union 2 to infinity. So if you remember, that's the whole real number line except for the number 2. So let's find the domain of g. G of x is equal to 2x plus 5 over 8. And you look at the denominator, you say to yourself, self, when is the denominator equal to 0? Well, the denominator is 8. And 8 is never equal to 0. Therefore, division by 0 never occurs. And if division by 0 never occurs, then your domain would be all real numbers, negative infinity to infinity. All right. So how about h? 5x over x squared minus 16. Well, in order to figure out where the denominator is equal to 0 on that one, we need to figure out where x squared minus 16 is equal to 0. And probably the easiest way to do that would be to factor that denominator. So, 5x, and that's the difference of 2 squares there, so that would be x plus 4 and x minus 4. Now again, I would want x plus 4 to not be 0, and I would want x minus 4 to not be 0. I can subtract 4 on both sides here. X cannot be negative 4. I can add 4 to both sides here. X cannot be positive 4. So if I want to remove negative 4 and positive 4 from the real number line, just as a recap in case you needed it, especially on the other one. So I don't want that one and I don't want that one, but everything else is okay because those are the only two values that cause division by 0. So here's where I get those intervals that I'm going to union together. The first interval is this guy right here. So that's the interval from negative infinity to negative 4. Then you've got this one in here, which is from negative 4 to 4. And then you've got this one right here, which is from 4 to infinity. So the domain negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. Let's do one more. So 3x minus 1 over x squared minus 2x minus 3. Now again, factoring the denominator is going to help us to be able to figure out the domain. This is 3x minus 1, and the denominator factors, so I got x and x. So I ask myself, what multiplies to give me negative 3 but adds to give me negative 2? The answer would be negative 3 and positive 1. Now remember, I'm going to take these, I'm going to say x minus 3 cannot be 0, and x plus 1 cannot be 0. You can add 3 to both sides here, so x cannot be 3. Subtract 1 from both sides here, x cannot be negative 1. So, the domain would be negative infinity. Now, I figure out which one of these comes first. So, the smaller one would be negative 1. Union negative 1 to the next one, which is 3. Union 3 to infinity. And if you have to draw a number line to figure that out, that's fine. Okay? All right, so that brings me to the next topic, simplifying rational expressions. It's important to understand that when you're simplifying these rational expressions, you have to divide out or cancel factors, not individual terms. So if I'm doing 4 divided by 2x plus 10, essentially what I can do is I can say, okay, this is 4 over, and then there's a common factor of 2, and then this is x plus 5, and then I can simplify the 4 and the 2 to become 2 over x plus 5. Notice that you cannot do this, so don't write this part. But 4 becomes 2 and 10 becomes 5. You can't just do an individual piece like that. You've got to be able to do the whole thing when there's addition or subtraction. Okay? So for instance, if I had 3 plus x over 3 plus 2x, you cannot do the following things. I cannot cancel the 3's. Because if I canceled those 3's, I would have to cancel something out of the x and the 2x, and there's not a common factor there. I also can't cancel the x's because of the 3's and the plus. Okay? That's a big no-no. All right? So this sort of thing right here doesn't simplify. All right. So what we're going to do is over this and over the rest of this video and probably the next video, we are going to do a bunch of examples in simplifying these rational expressions. So let's start out with 2x cubed minus 6x over 6x squared. So what we want to do is we want to factor these things as much as possible. Well, the denominator looks pretty much set. But the numerator has got a common factor. And that common factor would be 2x. So I can factor out a 2x, and then what's left over, if I take a 2x out of that 2x cubed, I'd have x squared. And then if I take a 2x out of 6x, I'd have minus 3. And now, since this part out here, this part right here, doesn't have any addition or subtraction in it, that's the part I can simplify right there. So notice that I can simplify the 2 and the 6. So 2 would become 1, 6 would become 3. And then notice that this x cancels with one of those, so I just have 3x. And so, as a result, I'd have x squared minus 3 over 3x. And please notice that the 3's don't cancel there. All right, continuing. Let's say I had x squared plus 2x minus 15 over 3x minus 9. So, I need to factor this. So in the numerator, I need to figure out what adds to give me 2 but multiplies to give me negative 15. That could be negative 3 and positive 5. And then notice that on the denominator, I've got a common factor of 3. And now observe that I've got x minus 3 and x minus 3. So those will cancel. And I'll have x plus 5 over 3. That's supposed to be 5. I think I'll save the rest of these for the second video.